Well, hey there, scholars. This is Dr. Franklin, and this is a mini lecture dealing with neuroethics and the future of cyber psychology. So, for this particular mini lecture, folks, I'm going to talk about key aspects of ethical decision making. This information is being provided in your chapter within the context of neuroethics, and I'm going to spend some time walking through key components of ethical decision making so that you can be aware of these foundational elements and build on them over the course of the semester. We'll talk about the history of neuroethics and the formulation of key ethics codes. The latter point is going to be essential because I'm going to want you to differentiate between some of these ethics codes. So make sure that you key in there. We'll talk about Martha Farrah's ethical toolbox, which actually incorporates a lot of the different ethical codes that we've talked about up to this point. So it incorporates deontological approaches, teleological approaches, consequentialist approaches. So make sure you zero in there and acquire that information so that you can recall it later. And then finally, we'll wrap up the presentation by talking about ethical issues involving iPhones in research. The way that it's discussed in your chapter is very general, but I want you to think about this content as it may be applicable to research scenarios involving iPhones. So, though it sounds like we're going to cover a prodigious amount of material, folks, this mini lecture is going to be very short. And as I go through it, it may even appear to be disjointed. But what I try to do is draw out the salient information that I want you to know as a cyber psychological researcher. Along the lines of ethics, there are several brain areas related to significant aspects of ethical decision making. In this portion of the lecture, I'm going to focus on the concepts that are extremely important in ethical decision making. The capacity for reflecting on and regulating oneself as a moral person involves consideration of one's own experience to ensure one is able to evaluate analogous situations in the future. So, self reflection and self regulation are extremely important in ethical decision making. Ethical decision making also involves one's experience of others' minds. This is important in ethical decision making because it helps us to realize that we are interacting with another being with intentions and motivations, which in turn will hopefully elicit empathy. This empathy will hopefully influence how we socially interact via our understanding of trust, fairness, and cooperation. Ultimately, moral judgments and decision making are an amalgamation of all the concepts or social cognitive processes I've discussed up to this juncture of the presentation. As we move into a discussion about neuroethics, it's important to note that the field draws from interdisciplinary research into ethical musings about the nature of the brain and the ways in which decisions are processed in and by the brain. The neuroethics builds on more established fields such as medical ethics, bioethics, and the ethics of genetics, but in its own right produces ethical quandaries that are relevant to cognitive, affective, clinical, and social neurosciences. When tracing the development of neuroethics, one cannot help but see how research that did not respect the rights and dignity of human beings prompted changes to ethical standards in biomedical and social behavioral research. This can be seen from prefrontal lobotomies conducted in the late 19th and early 20th century and the atrocities that occurred in concentration camps that led to the development of the Nuremberg Code in the 1940s. Several professional neuroscience organizations, councils, committees, and organizations, some regionally based and some international, developed throughout the years in an effort to cultivate standards that respect autonomy, rights, dignity, and beneficence. Once the atrocities of the Tuskegee experiment came to light, this led to the construction of the Belmont Report, and annual lectures on neuroethics occur in addition to revisions and reflection of the efficacy of current principles and standards. The areas that neuroethics cover is expanding into neuroeducation, neuroimaging, and brain stimulation, just to mention a few. As researchers become increasingly interested in investigating neural activity, New directions in science are more the product of new tools and technologies and not necessarily new concepts. Martha Farrah presents an ethics toolbox for neurotechnologies that involves principlist, deontological, and consequential ethics. The toolbox that she has developed is largely based on Beauchamp and Childress's list of specific principles, which include respect for autonomy, beneficence, non-maleficence, and justice. Deontological neuroethics involves treating humans as an end within themselves and not a means to something else. Deontological neuroethics shows up in cyberpsychology research when researchers insist that informed consent be used so that they do not violate a person's right to autonomy. Additionally, respecting and acknowledging someone's rights in cyberspace is extremely important and gives a person dignity apart from objects. Consequentialism is the ethical framework that judges acts as right or wrong depending on the expected value of its outcomes. An example of this type of ethics applied to a cyberpsychology research situation could be an institutional review board ensuring that a remote scalpel wielding robot would not cause harm to human beings. The Institutional Review Board, or IRB abbreviated, would likely want to see the study carried out with mannequins before putting the robots to use with human beings. Saving lives, pro, versus cutting and butchering patients, con, has to be assessed prior to moving forward with that type of research. The neuroethics toolbox offered by Farrah cannot be applied algorithmically to reach definitive solutions. Instead, the toolbox can be seen as a set of approaches to be used to identify and underscore pertinent reflections on given situations. Other tools should be included in the neuroethics toolbox, which may include descriptive information given certain cyberspace cultures, normative information, in addition to other ethical approaches like the Nuremberg Code, the Belmont Report, etc. Any approach should not be viewed as a panacea, and when in doubt or in conflict about an ethical issue, further research and consultation should be included in one's initial and ongoing approach to resolving the ethical dilemma. Given how iPhones are selling at an increasing rate since 2007, up to about 218 million iPhones a year, and it is a technology of the extended mind, ethical issues arise when considering how individuals use the devices. Rayner and Nagel identified three important issues that have import for further discussion. Number one, threats to autonomy from manipulation of technologies of a person's extended mind. Number two, threats to privacy by way of examination of a person's extended mind. And number three, cognitive enhancements via a person's extended mind. Autonomy may be threatened to the degree in which algorithms in the technology influence decision making processes. Some individuals rely on relational autonomy, for example, consulting with family members, friends, trusted professionals, etc. Some really rely on Google or whatever their app says. So, the degree to which the algorithm may affect one's autonomy can be through one, how persuasive the algorithm is, two, the gravity of the decision, and three, the algorithm's ability to identify the user's preferences. If one is able to reflect, they may be able to overcome the persuasiveness. For number two, the gravity of the situation is based on the potential cost and benefits of the situation, and thus the lower the cost and benefits, the lower the seriousness of the decision. Finally, computers' ability to identify preferences based on behavior could lead to an autonomy infraction if one is looking to think outside of their habits.